Hello and welcome back to Compiler Programming. Today I'm going to continue working on this userland managed implementation, and there are a couple of things here that's pretty low-hanging fruit on one hand side, but it's actually we can try to implement them in an interesting way. So we want Bitwise and Bitwise shift left operators to be available, but we actually only want them to be available for the compile time execution. We don't really care about them being available in the target architecture because all of this encoding is supposed to be handled at compile time. And maybe a couple of weeks ago, I introduced this new mechanism that allows me to write pretty straightforward functions that would be defined at the compiler side that are callable from the code. And this is exactly how we will try to implement this kind of operator. Okay, so we have this function, it accepts values and can return a value, and then we would need to have a wrapper for it. So if we look here, this is how we define it to be available inside the compiler, and then in a prelude, you can see that actually you cannot see it in the prelude. Well, this is the external function that I was talking about, but we can also provide wrappers if we need to, because this mass import is also one of those functions that I defined here. Like you can see it, mass import. Okay, now we need to figure out how we're going to do this. And the way we're going to do this is we are actually going to define an operator that will just forward these to a function. So the operators currently don't support overloading by themselves, and I might actually keep it that way as well. Instead, they will always have, like, basically almost always delegated to something else. They are sort of a syntax sugar rather than built-in construct. So if you look at operators here, operator, yeah. So we have a bunch of tests around operators, and I'm just gonna grab one of those tests, and this is what we are going to do. So we'll go here, and it doesn't really matter where we define it, but let's put it at the bottom. We'll have operator. I have no idea what the precedence is. I think for now I'm just cloning the precedence from Go. So Go operator precedence something. Go operator precedence language spec. Sounds good. That is very not useful. Operators and punctuation. Great. How about the precedence of operators? Okay, that is not great. So interesting. Operator precedence. Actually, we have binary op, relative op, add, and unary. So this stuff actually has the same precedence as multiplication. Okay, we can do that. I can look at the multiplication and see what the precedence of it is. It's actually also 15, so that's good. That means it is exactly the same as multiplication. We have now a left shift. Okay, and what it will do is it will say that the function will be called bitshift, and I think this is a logical left shift. Logical operators. No, shift operators. Okay, integer and signed integer. I see. So they also have only two shift operators like C, and whether it is logical or arithmetic shift depends on whether we are doing it on the uh, unsigned or signed types. Yeah, so this is unsigned types, then it is a logical shift. But I actually don't want it to do it that way. I think I want to have specific like logical shift left xy, and this is what it will try to call. I'm not even sure we need the curlies, but let's leave them for now. And yeah, so that would be the general function, and you can overload that function if you want to for your specific types. And this is exactly what we will try to do with the code here. So mass compiler external, let's go back to this code. Right, and let's mark this here. I don't actually need to copy because what it will do is I think we'll have to have several functions, one per type, which is kind of annoying, but I guess that it is what it is. We will start with the U64 version, and then let's see. Mass U64 logical shift left. That will return us a U64. And here would be 64 input and U64. I'm actually not sure if it is a U64. I think you are actually limited in the size of the shift. So I will do check on the limits in the, well, actually the only limit is for maybe for specific architecture, and then those specific architectures have to decide how to handle it. For now, I'll just try it this way and see if C compiler actually yells at me if I try to do it. And I will say return input shift. That seems reasonable. And now we can take this function, we can go in here, and we will take one of these and just, plug this in. Great. And the return type of it will be U64. It will only have one argument, which is like number. Doesn't really matter what we call here, it only matters for debug stuff. And it would be descriptor U64. So it takes, actually no, it takes two arguments, right? It takes the number and takes the shift. Okay. So does that build? It does build, but we need to now check if that works. So the way we want to check that is as follows. It should have a built-in compile time shift operator. That's actually quite interesting. So right now I defined it as right. So it is defined as compile time. Right. No, I think it will work, but I might need to change a few things later on. So let's say test. We don't need any of that. Any of that. Let's remove this stuff. And our test will be very simply, we will take 2 and shift it by 1. So this will test whether this at all works. And we'll also test is if result, let's take this, I guess I would call it checker. No, this doesn't matter. We need to say, put it here, right? Yes. Wait to 64. Well, in reality, it doesn't matter if it is 64 or U64, so I can keep it that way. And the expected result that I want is 4 because shifting by 1 is equivalent to multiplying by 2 for integers. So that's what is supposed to happen. I can do 64 result, or actual is this and actual is 4. Well, let's see if that works. I have no idea, but we can debug if it doesn't test. Okay, that does not seem to be working, and the reason it doesn't work is because I didn't correctly name things, right? Because here I expect it to be a logical shift left, but I provided it under this name. And there is actually a problem with what I'm doing right now because this is a compile time function. And right now there is no way on to overload on the fact that you have compile time values. So that is a bit awkward, I guess. But we can figure it out later. For now, I just wanted to kind of show you that mechanism and have some basic things working. Let's see if it does work. Well, that's not exactly what I wanted. So it looks like we have an infinite loop or something, which is bad. Let's bring up the debugger and see what's going on. No. We have an access violation, so we are trying to call something that we absolutely should not be calling. And this happens when we run checker, okay? Let's break here, run, and go from there. So actually, yeah, it needs to be here. We need to go to disassembly, then we can step inside, and we are indeed in a very bad place. Interesting. Huh. So first of all, let's verify that this is indeed connected to the operator, and then we'll go from there. So does this work? No. It sounds like I'm doing something really wrong here, and I actually know what it is. Probably should protect myself against that in the tests. But the problem is that this is supposed to be inline source function. Right. Because previously we would not compile the function correctly, and that's not great. Okay, let's try again. Okay, the test fails, but that's because we are doing the wrong thing. Let's try again, but now it's the right thing. Token match. That is very curious. So our test actually passed, but we managed to break something else. So we managed to break Fizzbuzz for whatever reason. Which is very curious to me. Okay. Just to verify, if I undo this, Fizzbuzz works. Let's look at Fizzbuzz. I'm pretty sure I'm not accidentally using shifts here. The only thing I can think of is that it somehow messes with this stuff. So what if we move it up? Okay, that helps. Something is very, very strange going on here. So I think it is somehow connected with the syntax thing. So I'm not sure I want to debug that right now because it's not connected to what is going on. I don't know, should I like do this stuff or something? Force line termination. Okay. Is it line termination of these ones or other ones? Okay, something is awkward here, but again, not connected to what we're doing right now, so that goes. Wait, does it just randomly fail? No, okay. At least doesn't seem to be. Fine. So that's good. This is basically what it should look like. Just to bring the example home, let's do another one, I guess, or you know what? Let's actually define multiple of them. We will use some macros on both sides to make a bunch of these. So I believe I have, yes, I have this mass process built-in type and mass enumerate built-in types, and I'm using it in some places. Or maybe I do not anymore. But I believe the way it works is you define this function that is mass process built-in type. You say define mass process built-in type. It accepts a name and a bit size. So we don't actually care about bit size, but we will still have it. We'll have like type bit size, and we are gonna do this thing, right? Let's bring it in one line. Type logical shift left. This would be the input, like this, and the actual shift amount is always unsigned. Like it doesn't make sense to have a negative shift amount. It's just weird. So yeah, this is what it will do. Then you do undef here, and you just say mass enumerate built-in types. I believe that's how it works. If I haven't screwed up, then the code should still work. Illegal left operand, right. I don't want built-in types, so I actually want like enumerate integer types or something, and that would be without these two, and then we could say enumerate integer types, and then you would have the rest of this. Is this better? Okay, that seems to work. Let's check that our test still passes. So it is intermittent. That's very, very strange. Okay, I have no idea what's going on there, but as I said, let's not think about it. I will debug it separately. Our actual test actually passes fine. Okay, but now that we have these things for all types, we could actually do even more crazy macro stuff where we will define it for these things. So how does it look like? We need to put the type in here. We need to put the type in here. In here as well, but this one stays U64. So if I haven't messed it up, then this should work, and we should create a bunch of overloads for all the different types of that we want. Let's see if that actually works. Well, again, there is this bug with Fizzbuzz for some reason, but the actual operators seem to still work. Testing the different types is actually kind of awkward because we want these to be compile time values, and well, I guess I can make it work. I can do something like cast S32 so now it should be an S32 value, and let's see if we'll actually know if it works by changing type here, and it will then disallow me to return a larger type. So let's try that. Target descriptor is descriptor 64. So something did not work like I wanted it to. Let's take a brief look and see what's going on. Where are we? We are inside of a sign. Okay. And then we say type and exception. So what is actual exception? Target descriptor is descriptor S64. And this one, accept if integer immediate fits. If source descriptor is a source type, so we are trying to, I guess it's trying to put a U32 into an S32, no, U64 into S64, so it didn't actually work with this stuff, which is unfortunate. I guess I know another way how to try to force it to be the right thing. Test S32, so we can say that this is an S32, but it is a macro. And now if we say test S32 of 2, then this should be what I want, I think. Unless this whole logic is screwed up, which it very well might be, but again, that's sort of not connected to the topic at hand, even if it is. Okay, so now we were not able to parse it because I forgot a new line here. Let's try that again. So it really does not like what I'm doing here, which is very, very interesting. What if I try to call the logic directly? Logical shift left is of x and 1. Is that any better? No. It is still very, very unhappy. Okay, but that has something to do with the way we cast literals to numbers, and again, that's not really what we're interested in today. So let me undo all of that jazz. For now, the good point is that it still works. We have even if we define multiple functions, so we technically have functions for all the different types. They're just not being used. And let's actually do the end version of it as well. So because that's also something that we need. Right, we have bitwise end operator, so we can do that. Bitwise end operator in a sense is actually easier because this one has the same type on both sides, and we can say logical, actually bitwise and for good measure we can also do bitwise or, to be honest. Bitwise or, it's here, bitwise or operator, it's like nice to have. And since this should be pretty easy for us to do, why not do that? Okay, this would be bitwise and this would be bitwise or, and let's go into here. For now, I'll just copy paste. If I decide that it grows too large, I can introduce another layer of macros, because we could technically put this operator into a macro as well, and then this would generate all of them. Actually, we don't need it to do it quite like that. We can put them here bitwise and type A, and B. Bitwise or, right, we don't need these. So first, let's verify that it still builds. Actually, that should be or. And we can also add bitwise and. So what would be a good test for it? Well, let's do like, oh, we actually have bitwise bit numbers. So that would be a good show for that. And if we say 0b 101, then we should get or actually like this. Yes, and the result should be 2, so the result should be 0b10. This is what should happen. This is bit compile time bitwise and operator, and the last one is or. That actually is okay example for or as well. We expect this to be a 111. Right. Well, let's try to run these. And they will obviously fail because I have not actually defined the right thing. In here, we need to have or and you have or. So this is bitwise and this is bitwise or. Let's try it again. Yeah, again, the Fizzbuzz is, there's something really wrong with Fizzbuzz. Does it like help if I move it again or something? I don't know what's going on with that. I think it doesn't like these syntax rewrites, so maybe to stabilize it a bit, I will actually roll them back. And pull request, you can go to code, commits, and there is this. Oh, where is it? Oh, I haven't actually pushed this code yet. Well, that's awkward. Well, whatever. And the point is, we don't care about that example. It doesn't fail for the reason that we have here. It fails for something else. I don't want to undo the function definition here, so I will keep it as is, I guess. Right, that is probably all. So again, as you can see, the tests for the operators actually pass. Everything is working as we expect it to be working, and sometime off camera I will figure out what the hell is going on with that Fizzbuzz example and why does it fail. But for today, that's all. I think that this setup where we can easily delegate some work, at least for compile time execution to these simple defined functions that we can also auto-generate is pretty cool, and this would allow me to easily build up kind of a library of functions and remove later on. So I have right now these plus or minus, they are done in this very awkward manner where I have to manually check for the right combinations of types and casting up and casting down and whatever, and all of that will actually be replaced by exactly the same thing that we just did for bitwise and or. So I think that's pretty good. Right, that would be all for today. Thank you very much for watching, and hopefully see you next time.